Hello everyone. In this video, I'm gonna explain about Kubernetes architecture overview. Like in this video, I'm going to show you documentation and I have prepared some video over here so that I can explain you about how it would work in this architecture, like related to pods, clusters, and how they connected. So I will show you my screen and then we will start again. We will start for this process, like how it would process and how it would make it in this architecture. I have prepared one documentation and then I have prepared some video over here. Let's start. This is the presentation which I have created, Kubernetes architecture. So in this, we have started with this master and client server architecture. Basically, Kubernetes follows client server architecture wherein we have master installed on the one machine and nodes on separate Linux machine. As you see, this is the this is a diagram like masters and nodes, where nodes are connected with the pods. In every node, they have two pods, and master they have a cluster, controller, scheduler, and API server. They have given the command. They have taken the commands from the kubectl local workstation, as you see in this video. In this screen, they have mentioned this type of masters, and this scheduler will connect to every nodes, and that nodes have a particular pods over here. And now we have to understand like what is Kubernetes master machine components. First is etcd, like it stores the configuration information which can be used by each of the nodes of the cluster. It is highly availability key value that has stored and distributed among the multiple nodes, and it is accessible only by the Kubernetes API server. As it may have some sensitive information, they have provided like the value stores accessible to all. So that's the purpose of etcd. And next will be like API server. API server is like a client server architecture, means like application programming interface. It is so Kubernetes is an API server which provide all the operations on the cluster using API. API server will implement an interface, which means different tools and libraries can readily communicate with it. Then we have used Kube Configure. It's a package that is a server-side tool that is used to communicate, and it exposes the Kubernetes APIs. Next one is Controller Manager. Controller Manager is responsible for most of the collectors that regulate the states of clusters and perform the tasks. Generally, we have used this daemon which runs on the non-terminating loops and is responsible for collecting and sending information to API server. Then we have go for the scheduler. Scheduler, this is one of the key component of Kubernetes master. It is the server service in master responsible for distributing the workload. It is responsible for tracking utilization of workload on the cluster nodes, and then placing the workload on which resources are available and accept the workload. So these are the things that are mentioned in this architecture. And then we have understand like what is worker and slave node. This is the most important thing in Kubernetes. Mostly they have worked on worker and slave nodes. Worker nodes are another essential component which contain all the required services to manage the networking between the container, communicate, and with the master nodes, and which allow to assign resources to scheduler container like Kubernetes that gets the configure of pods from the API server and ensure that the described container are up and running. Then we go for the Docker container. Docker container runs on each of the worker node, which runs the configure pods. Then we go for the kube proxy. Kube proxy acts as a load balancer and network proxy to perform service on a single worker. Pods is a combination of single or multiple containers that logically run together on. Now go for the Kubernetes concepts. This is usually make of Kubernetes require understanding the different abstractions it uses to represent the state of systems like services, pods, volumes, namespace, and deployment. Pods generally refers to one or more container that should be controlled as a single application. It has encapsulated application container, storage resources. They have unique network ID and other configurable for how to run the containers. Then we go for the service. Service is like a pods are volatile. That the Kubernetes does not guarantee or give a physical pod with a kept life for the instance and the replication controller that might be kill and start a new set of pods. Instead of service represent a logical set of pods It acts as a gateway that's allowing client to send requests to the service without needing to any track of physical pods actually make up the service. Then we go for the volumes. Volumes is similar to the Docker, like container with volume in Docker, but the Kubernetes volume applies to the whole pods and it is mounted on all the containers in the pods. It guaranteed that the data is preserved across container restarts when we restart the container, and the volume will be removed only when the pods get destroyed. So that's the purpose of volume in Kubernetes. Then we go for the namespace. Namespace is a virtual cluster that a single physical cluster can run multiple virtual ones. Intent for environment which may users spread across multiple teams or projects. For the isolation concern maybe it's like and it cannot be accessed resources in a different namespace. So they have allocated the resource quota so that avoid consuming more than the share of physical clusters. Then we go for the deployment. Deployment describes the states of pods and replica sets in the YAML file. When we created a YAML file, they have described that pods and replica. The deployment container then gradually updated the environment, for example, creating a detecting replica until the current state matches the desired states specified in the deployment file. For example, if YAML file defined two replica for a pod, but only one is currently running, the extra one will get created. So that is the replica managed all deployment should not be manipulated directly or for the new deployment. Now I will show you one video. I will show you which that video I have created our node processes related to architecture whole. Now I will show you on that. I will explain everything on that. Then you can understand like why would use Kubernetes architecture is important for us. I have shown this node processes where we have covered. I have creating the videos over here like how to create an architecture, how the process they have followed. So now I am showing you this video where we have covering all the presentations level like how they have architecture will using node and they have used clusters and more many things. So now I am showing you. So this is the node just where we have K8 clusters we have working on it. So most probably they have like a Kubernetes clusters. They have two apps component. They have worker server on nodes and each node will have a multiple application pods. So recently they have communicate does it using three processes like they must install on every node that are used to schedule and manage those pods. So nodes are the cluster server that actually do the work that that's why it's something also called a worker node. So the first process that need to be run on every node is the container runtime in my in the example Docker, but it's sometimes they have technology as well because application pods have container running inside a container runtime needs to be installed on every node. But the processor that actually schedule those pods and the container that underneath is a Kubevalidity, which is processes of the Kubernetes itself, unlike container runtime that has interface with the both container runtime and the machine, the node itself, because at the end of the day, Kubevalidity is responsible for taking that configurations and actually running a pod or starting a container. That is inside and assigning resources for node that have container like CPU, RAM, and the storage resources. So usually Kubernetes cluster is made up of multiple nodes, which is almost contain the container runtime and Kubernetes services installed. And you have the 100 of those worker nodes, which will run other pods and container. And replica of the existing pods like my apps and database pods in the example, and the way that communication between them work is using services, which is sort of load balancer that basically catches the request directly to the pods or the application like database, for example, then they forward this respective pods. And the third process is that is responsible for forwarding request from services to pods is actually like a queue. It is like a proxy that is almost installed on every node. And the queue proxy has actually they have logical insight that they make sure that the communication also works in the prominent way. with a low overhead of for example, like if an application, my app replica is making request database instead of services, just randomly forwarding the request to any of the replica, it will actually forward it into the running on the same node as the pod that initiated the request. Thus, this was avoiding the network overhead of sending the request to another pods. So they have summarized these two Kubernetes processes like Kuvalidity and Kuproxy. So they have Kubernetes workers. They have along with the independent container runtime in order for Kubernetes clusters to function properly. But now the question is that how they interact with the um, clusters. How we decided that node or new application pods or database pod should be scheduled, or if the replica pods dies, what processes actually monitor? Restart it again, and we have another server. How does it on the clusters to become another node and get pods and other components created on it? And answer is like managing processes are done by master node. Now we have master processes where we have server nodes with completely different processes running inside these four processes that run on every master node that control the cluster state and the worker node, as well as they have the first server services is like API server. So when you want to deploy a new application in a Kubernetes cluster, you interact with the API server using some clients. It would like UI like Kubernetes dashboard, could be command line tool like Kubernetes, and the accumulate this API. So API server is like a cluster gateway which get the initial request for any update in the cluster. So that is the process for the cluster they have using it and processing this process like a gatekeeper of the authentication to make sure that the only authenticated and authorized request get through to the cluster. That means whenever you want to schedule new pod, deploy new application, create new service, or any other components, you have to talk to the API server on the master node. And the API server then validate your request. And if everything is fine, then it will forward your request to the other processes. In order to schedule the pods or create this component that you requested, and also if you want to query the status of your deployment or the cluster health, etc. You make a request for the API server and it gives to your response, which is good for security because you have the one entry point in the another master processes, like only one entry point into the cluster. And if you send that API request to the schedule a new pod API server, after it validates your request, will actually over the schedule in order to start the application pods. And one of the worker node, and of course instead of you randomly assigning that any node schedule has its whole intelligent way of deciding on which specific worker node the node pods will be scheduled on next component will be scheduled like a. So if first it will look at your request and see how much resources the application you want to schedule will now have the CPU and how much RAM, and then it good gonna look at the end. It's going to go through the worker nodes and see the available resources. We have like one of them is like and if we see another node is the least busy on is the most resources available. It will schedule the new pods on the node. An important point here is like scheduler just decided on which node a new pod will schedule. The process actually does the scheduling that actually starts to get the request from the scheduler and execute the request on that node. The next component is controller manager. The controller manager will require to because they have crucial component because what happens when ports dies on any node, there must be a ports night for any node, there must be a node for that, and then you schedule those ports as soon as possible. So what controller manager does is detect state changes like crashing of pods, for example. So when pods dies, controller manager detect that and tries to recover the cluster state as soon as possible. And for that it make a request to the scheduler to reschedule those dead parts in the same cycle happen. Here we have the cluster we have decided based on the resources cluster, which we have to note should restart those ports again and make requests so the corresponding kubelets on those worker nodes to actually restart the pod. And finally, the last master process is like etcd, which is the key value of the store cluster state. So you think that is the cluster brain actually, which means that every changes in the cluster. For example, we when a new pod gets scheduled, when a pod dies, all these changes get saved or updated into this key value stored for the CD stores in the cluster brain. Is because of all this mechanism build schedule controller manager etc worker because of its data. So for example, how to reschedule now, what resources are available on each worker node, or how does controller manager know that a cluster state changed in some of the way. And that's Kubelets restarted new pods upon the request of a scheduler. And when you make a query request to API server about the cluster health, or for example your application deployment state, wherein API server gets all its state information from, so all the information is stored in a etcd cluster, which is not stored in that the key value stored in the actual application data. And for example, if you have a database application running inside of the cluster, that the data will be stored somewhere else, not in the etcd, which is just a cluster state information, which is used for master processes only to communicate with them, the worker processes and the vice versa. So now you probably already see that the master processes are absolutely crucial for the cluster operations, and especially the etcd stores which contain some data must be reliable, stored on replicated. So in the practice, communicate cluster is usually made up of a multiple masters, where each master node run its master processes, where of course the API server is load balancer and the etcd stores from a distributed storage across all over the state. So that is the distributed stores. And now cluster setups, they have nodes of look of the replication example. The cluster setup so is very small cluster. You have probably have two master nodes and three. They have two master nodes and three hardwares. So two master nodes and three worker nodes. Actually, the master processes are more important. They have actually the less loads of work, so they need less resources like CPU, RAM, and storage. Whereas the worker node running through the container inside, therefore they have need more resources. As the application complexity and the demand of the resources increase, you may actually add more masters and node server to your cluster, and thus forming a more powerful and robust cluster to meet your application requirements. So in the existing Kubernetes cluster, you need to be add new master or node server pretty easily. So if you want to add a master server, you install all the processes on its added to the communications. They have get new bare services, install all the master worker node processes, and they have add to the cluster. So these are the services which are followed in the application Kubernetes clusters, Kubernetes architecture. So so these all are the things which are covering in this video, and in the next video we will see the most functions of Kubernetes, like more activities we have used in our upcoming videos, like what is kubectl and how it described with the example bash completions, and main important we have created a pods in the coming videos. So that's all for the today, and this is all my videos. We will back in the next video. Thanks for watching.